Greetings everyone, this is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next of our What to Look For in the Night Sky series. In the series there, this video is for January 23rd, 2023. So what we're going to look for this week is, we'll start, we got a couple of different things. We got a busy board as you see behind us. We're going to start by saying, okay, if you go out and you draw the line, we've talked about this many times before, you draw a line that runs north to south directly overhead, that's the meridian. And a lot of times we like to look for things that cross the meridian at midnight. So if we see something that's crossing the meridian at midnight, that means it's up and observable all night long pretty much. You know, if it's way south or way north, depending on where you are, you might not be able to see it all night long. But it's going to be the most well placed for observing that it's ever going to be. And right now, Cancer, the constellation of Cancer, sort of fits that bill. It's transiting, it's crossing the meridian at midnight, close to midnight. And it's high enough in the sky for mid-northern latitude observers like myself to be able to see all night long. So let's start here and try to work our way to Cancer. Cancer is an interesting constellation, in part because it has very faint stars, and so it's very hard to see. And so one of the easiest things to see in the constellation is actually the Beehive Cluster, an open star cluster right in the heart of the constellation. And it's a big, beautiful open star cluster, easy to see with binoculars. You should be able to see it. If you have dark skies, you should be able to see it as a fuzzy patch there without any optical aid whatsoever. So in this coming week, if you've got dark skies, anytime you get out, evening to morning, in the mid-northern latitudes, look for M44, this fuzzy patch in Cancer. It's going to guide your way to Cancer. Now, if you're out at midnight, you're looking sort of due south for this. I'd be looking due south around midnight. If it's a couple hours before midnight, I got to look east of there. And if it's a couple hours after midnight, I got to look west of there. And how I'm going to find it is that the twin stars, Castor and Pollux, will be over here to the north and to the west of the Beehive Cluster, and the big bright star Regulus in the backwards question mark, the sickle of Leo, is down here to the south and to the east of the Beehive Cluster. If I draw a line that connects Regulus to Pollux up here, M44, the Beehive Cluster, falls just below that line, and it's a little bit closer to Pollux than it is to Regulus. Remarkably, I think I've actually drawn this fairly accurately. My drawings never ever quite work like I want them to, but you sort of see how much closer to Pollux it is than to Regulus, and it's just barely below that line that connects those. So you go out and you find your bright stars, Castor, Pollux, and Regulus, and see if you can see a fuzzy patch that's in there. If you don't see it, try binoculars. Try to scan that region and see if you can find the Beehive Cluster. Now the Beehive Cluster sits right at, so that's our initial finder chart to get us in the right general area. Now let's try to find the stars of Cancer. The Beehive Cluster sits right in the heart of the constellation. And if we move this direction to the south and to the east, so we're going to move south and east about 2 degrees. Remember, your finger width held out at arm's length is about 1 degree, and your fist is about 10 degrees. And so a couple of finger widths maybe, down to the south and to the east of the Beehive Cluster is Delta. And Delta is a 4th magnitude star. It's about 3.9. All of these stars are going to be about 4th and 5th magnitude. You got good dark skies, you can see them. They're not going to pop out to you. They're not going to be big bright stars. That's what makes it such an interesting constellation. Is this cluster, this is another cluster I didn't draw down here, M67, is another old open star cluster. These are kind of the biggest, brightest things in there. It's a little bit harder to see, but binoculars could pull that out for you. A telescope for sure, a small telescope. Acellus Australis, this is sometimes called this Delta star. Now we move another 7 degrees, so that we're about a full fist width in that direction down from the Beehive Cluster, and we come to the Alpha star, which as you see is a little bit fainter than the Delta star, so it's not quite what you would expect. Acubens, this is sometimes called, in the vicinity of M67. It's a 4.3 magnitude star. Now, if we hop from there, we're going to take a break. Let's come back to that. So you've got this line that comes down here from M44, the Beehive Cluster, through Delta, down here into Alpha. So that's your first task for the week, is let's go out and try to find those stars. Let's try to find the Alpha star and the Delta star in Cancer. Now we come back up and make sort of a right triangle, and go this other direction, a right angle. Let's go make a right angle this other direction through the Beehive Cluster and about 7 degrees out. So about the same distance between delta and alpha, we come to zeta out this direction. So we can draw that in there. Zeta is about 4.7 magnitude. So again, all of these stars, 3.9, 4.3, 4.7, these stars are all relatively faint. Iota, I didn't write the magnitude down, but it's going to be about the same thing, right? It's going to be about a 5th magnitude star up that direction, and it's going to go straight up, split this right angle, and go straight up from that, and you see the shape, the nice shape that you have drawn right there. That's about 9 degrees. That's about the same distance from the Beehive Cluster down to Alpha up to Iota. Okay, so that's the basics of the constellation we're looking for. There are some fainter stars along these paths, and you can look for those fainter stars and see if you can identify them, and that could be a lot of fun. Let's go back to Alpha. If we look at Alpha up close, so this is a close-up view of Alpha, and Alpha has another star that's a little bit brighter, about 2/3 of a degree this direction down here. About 1 degree, making a more or less isosceles triangle, about 1 degree down this direction is RT Cancri. RT is a designation. When you see a double-letter designation like that, it means you got a variable star. And this is a pulsating variable star. It's the kind of star we would call a semi-regular variable star. And it changes brightness by about a factor of 3. So at its brightest, it's about 3 times brighter than at its faintest, but it's a relatively faint star, sort of in the 7th to 8th magnitude range. Binoculars would show it for sure, and a small telescope would be even better. If you have a small telescope with a good wide angle field of view, which is what you would want to do this kind of work, you should be able to get all 3 of these stars in the same field of view. Now, it's going to be a little confusing because there are other stars in the field of view too, but you should be able to get all 3 of these stars in the field of view, and there are 3 of the brighter stars in there, especially these 2. And what's nice about it is it changes. The reason I picked this one, there's a number of long-period pulsating variable stars, Mira stars or semi-regular stars. And the reason I picked this one, it's a little bit easy to find relative to Alpha. So we can do our constellation mapping here, our asterism mapping, and we can find RT Cancri fairly well. But it also has a relatively short period for one of these long period pulsating variables, these asymptotic giant branch stars that are pulsating in and out and getting brighter and dimmer. And it has a period of about 90 days, and that's relatively short. There are shorter ones for sure, but that's on the shorter end of the range of variability for these stars. So you don't have to watch for a long time. If you start this week making sketches of this region of the sky, and you watch through the upcoming spring, as we get to spring in March, you will have seen this star change dramatically, and this will have been a fun project to note how much the brightness of this star, the apparent brightness of this star changed as you watch this. So it's going to get about a factor of 3 brighter or dimmer over the course of the next, sometime in the next 2 or 3 months, you will have seen this get a huge factor brighter or dimmer. Not huge by standards of these stars, but a factor of 3 in brightness is a very noticeable change. So if you got a small telescope, you got your binoculars, and you want to try something fun, give that a try, and go ahead and start this long-term observing project. Now over this direction, Zeta is one of the more interesting multiple stars in the sky. So Zeta has a close pair of stars that has a period of about 60 years, and unfortunately it's about an arc second is all that separates those stars. So it's a challenge. If you've got a turbulent atmosphere at all, you need a pretty good telescope to try to pull this apart under the best of conditions. But it's an elliptical orbit. It's got a compressed orbit, so it gets closer and further away. And unfortunately, right now the separation of these pairs is not at its widest. So in that 60-year period, right now they're pretty close. So my guess is you'd have trouble finding those 2 stars. But there's a third star that is part of the system and is orbiting around these other 2 stars, and that's about 5 arc seconds, and that's a beautiful double star for small telescopes. You got your small telescope out doing some of this other work, come on over here and check this out. It's got a period of about 1,100 years. So we don't have to worry about that closing up on us here in the next few years. So see if you can pull those apart. The Zeta Cancri star there would be great. So that's what we got. Go out, find the Beehive Cluster. It's worth it just for that. The Beehive Cluster is a fantastic object, and it's great in binoculars. It's not quite so good in a small telescope because it's so big, it's very hard to get a wide enough field eyepiece to gather all those stars. If you can, it's spectacular, but you probably don't have that eyepiece. Maybe you do. If you do, congratulations. So anyway, there you go. Find the Beehive Cluster and get you started on searching the stars of Cancer this direction. If you want to come down here and find M67, I highly recommend it. It's a great cluster too. See what you can do with Zeta Cancri, and see what you can do with RT Cancri, this double star, multiple star, and the long period variable star. Now, one more thing to think about this week, really two more things to think about this week. The moon is a crescent moon. By the end of the week, it'll be a gibbous moon. It is waxing and filling out and doing what it does, which is sliding easterly against the background stars as the week progresses. Early on in the week, so on the evening of the 25th, so I guess that's midweek, it's not that early now, is it? So on the evening of the 25th, the moon will be about 25% full. It's a nice crescent moon. It's what you look at. If you were going to draw a crescent moon for somebody, that's probably about what you would draw as a typical crescent moon. Not a real thin crescent moon, but something like that is going to be sitting just about 2.5 degrees below Jupiter. So Jupiter, big, bright, star-like object in the sky, going to be a beautiful pairing on the evening of the 28th. Go out just after dark. Take a look to the southwest and see if you could see what you see if you enjoy that view of Jupiter and the moon there together. Now, on the evening of the 28th into the early morning of the 29th, so we're talking about Saturday night into Sunday now, at the end of the week, the moon will have slid quite a bit further to the east, and it'll now be past half full. So now it's made it to the gibbous portion of its phase, and it's just over 50% full, about 55% full on this night. And it's going to slide right above Uranus. And so at this point, you're still looking, you go out anytime after dark till just, till midnight or 1 in the morning or something like that. And you're still looking west of due south, but not nearly so much as you were with Jupiter up here. And the moon will be within about 3/4 of a degree. That amount of separation will be changing over the course of the night, so it depends where you are when you're looking. But a 1/2 degree to a degree between the moon and Uranus, a nice close pairing. Now, I've tried this before. We talked about this once this last fall, if you've been watching these videos and memorizing them. I don't know why you wouldn't be. But we talked about this when this happened earlier in the fall, and it was very hard. I've tried this a few times to go out and see Uranus with a pair of binoculars. It's certainly bright enough that you can see it with a pair of binoculars if you don't have a bright moon nearby. But we have a pretty bright moon nearby. And so it's not quite as bright as it was the last time we talked about this. So you might try it with binoculars, but a telescope's going to be a lot better for you. It's going to make it a lot easier if you have a nice wide eyepiece on a telescope to see if you can see Uranus and the moon there together. Maybe you can see it with binoculars. Worth giving it a try. Anyway, this is what we got for you. Go out, enjoy the stars and the open star clusters and some of the things going on in Cancer, and then watch the moon make really beautiful pairings with Jupiter at midweek and Uranus late week. And I hope, as always, that you have good skies and you have a great week ahead. And again, as always, thanks for watching, and we'll have something new for you next week.